Hi everyone. So today we're going to talk about what we discussed on Friday during our Google Meet. Rational functions that can be simplified. So what happens if you have a binomial in the numerator and denominator that can be canceled out? Before that, I want to jump in for a do now. Find the domain and range of these functions. So pause the video and do that. So basically, you're finding your asymptotes, right? So your domain, all real numbers, except where can the bottom equal, where would this equal 0? Except x equals 8 over 3. Your range is all real numbers except, what's your asymptote? Your horizontal asymptote, look at my x's, y equals 2 over 3. The graph won't cross that. For this number 2, domain, all real numbers except x equals 3. And the range, oh my goodness, I keep putting the R, all real numbers except, so this one, we have 2x over x plus 4. 2 plus 4 is 6. All right, so that's your domain range. All right, so how does a common factor affect the graph of a rational function? So the factor will create a hole instead of an asymptote. So if we look at this one, y equals, if I factor that, I get x plus 4 over x plus 1, x plus 4. So that x plus 4 ends up canceling out, and we're left with 1 over x plus 1. However, the original function still had that 4 in there. So there is a hole at x plus 4 equals 0. So at x equals negative 4, there's a hole. And that point ends up being negative 4 comma. If I plug in negative 4 into this, so negative 1/3, there's a hole in this graph at that point. And that only happens when it cancels out. So anytime the term x minus a is canceled out of a function, there is a hole at the point a f of a. X equals a is not a vertical asymptote. All right, so we're only going to do 3 problems today. So start by factoring. So if I can factor that negative 2 out, and I'm left with x squared minus 16. So that's x plus 4, x minus 4, all over x minus 4. So y equals negative 2 times x plus 4. Sorry, my rating is not good. So negative 2x minus 8. So this is actually a line, right? So the domain is all real numbers except x equals 4. You cannot, even though it canceled out, it's still not in the domain of the original function. And the range is going to be all real numbers except, what do we get when we plug 4 in? Negative 16. Y equals negative 16. All right, so I'm going to plot this. Negative 8, negative 2. Did I do something wrong? Oh, positive 4. Oh, man, it doesn't even fit on the graph. This is a terrible example. Sorry, guys. So basically, this thing looks like this, and then down here at 4, there's a hole. So it's a line with a random hole in the middle of it. And that's called a discontinuity. You get into that in calculus. Discontinuity. I've seen some Algebra 2 classes get into it. That phrase, I'm not really going to... It's really, that spot is a discontinuity. All right, pause the video, cancel out, draw the function. So again, I'm going to factor. Let's see. I messed this problem up. It's supposed to be minus 15. X. This is a what did I do? This is a terrible problem. It's supposed to be x squared plus 2x minus 15. Because it's x plus 5, x minus 3. Wow. Sorry. I haven't done that in a while. Alright, so we get 2 over x minus 3, which means my vertical asymptote is at x equals 3. My horizontal asymptote, y equals 0, and I have a hole at negative 5, comma, 2 over negative 8, so negative a quarter. So negative 5, negative a quarter. So I'm just going to put that right in there. I'm going to draw in my asymptotes. So 0 and 3. I'm going to pick some points. So if I put, oh no, I meant to have that as, all right, so 4, 2, 4, 2, 5, 1. So that's this one. And then negative 1, no, 2, negative 1. Did I do that wrong? If I plug in negative 5, oh no, that's right. Okay. And positive 1, I meant to make that positive 1. Ugh. Positive 1. I got negative 1 again. What did I do wrong? That's a negative 2. I should probably redo this video, but I don't want to. Alright, so at that point that I had there, I filled in that hole. Right? So it's everything is exactly the same, but at that point we're going to put where the hole is. Alright, this is the last one. This is it. Pause the video, try it on your own. Alright, see if I can get through this without making any mistakes. Alright, I'm going to factor the top. I can factor out negative 2x out of the top. And I'm left with 3x minus 7. The bottom, difference of two perfect squares. So the 3x minus 7 cancels. So my function becomes negative 2x over 3x plus 7 plus 2. So this one's going to have some gross numbers. The vertical asymptote is at x equals negative 7 over 3. Our horizontal asymptote is at negative 2 over 3 plus 2. So what's that? 6 over 3, 4/3. So that's obnoxious. So negative 7/3, that's just past 2. Oh. So there's my vertical. My horizontal is just past 1. And my hole is at 7 over 3, comma, ugh. I don't want to plug 7 over 3 into that. That's terrible. Alright, I'm going to use my calculator to do this because that's annoying. Alright, so 7 over 3. Oops. Alright, so we get negative 2 divided by I got 5/3. So 2 and change, 1 and change. So it's like, my hole's around there. All right, I'm going to be lazy. I don't want to plug numbers into this. This is terrible. If I plug in 0, 0, 2. All right, so those are my points on this side. Ugh, I'm just gonna, I don't feel like it, guys. That's it. That's our graph. Sorry, my left side's ugly because I didn't feel like picking points. That's it. So cancel out. Take that 0, 3x minus 7, right? The thing that canceled, set that equal to 0. You get 7/3. 7/3, and then you're gonna plug into what you get after you cancel out, whatever. So f of 7/3, and that's the hole. That's where your hole is in the graph. Okay, that's it. All right. Have a fabulous day. Do your homework. Email me if you have questions.